Hi, this is Stephen Neshiba, and I'm just here to get you started on the computational exercise on transition metal complexes. So, as you can see, I've got Spartan launched here, and I'm going to go to the inorganic tab, and I've already selected chromium, which you do by pulling this down and looking for chromium. And I also just selected so that there's one thing attached, because the truth is I want to get rid of even that one thing by going to this delete button and doing that. And so now we're set to go on that. I'm going to go to calculations. We want to select a B3 lip calculation. And for this one, we do want a neutral charge, but we want 6 unpaired electrons. Now, ordinarily, you would just press submit, but it takes about a minute to run. So I'm just going to click on this one here. And now I've already done the calculation on it, so I'm going to bring up the energy ladder. Now, what you want to do is go to this the A column, not the B column, and just click somewhere up there. Even though it's pretty compressed, you can still see what's going on if you just press on it and then figure on laddering up and down. So there's an S orbital. It's a 3s orbital, and now I think that's going to be a 3p orbital. Okay, and I'm keeping on just using my up arrow to pick up some more of these. There's another 3p orbital and another 3p orbital. Now, you might expect the next one to be 3d, but in fact, the next one in energy is this 4s orbital that you see here. All right, that's fine. And then the next one now should be some d orbitals, and you'll see that there are 5 of them. And check out the energy down here. It's around -2 EVs, and hopefully they're all 5 of them have the same energy. All right, so once you've done that, now then what you're going to do is build the ammonium complex, which is 6 ammoniums around there. And just to kind of show you, I've already started that, but just to show you how you would start it, you'd once again go for chromium, and but instead of going for 1, then you'll say I want 6 things attached to it, like that. And then what you're going to do is go down to ligands here, and one of these set of ligands will be an ammonia. There we go. So I'm going to choose ammonia, and then you just click on here to pick up all the ammonias. You'll do all 6 of them, just like that. Now, what I recommend when you do this is press the energy minimize button first, and that'll kind of put things in pretty much the right arrangement. Then you'll go to calculations, and once again we want to go through B3 lip, but because this is it's a 3 plus, it's chromium 3, we want that, and it turns out the number of unpaired electrons is 3, and everything else would be good to go on this. Now, you would normally submit this, but I'm going to just say cancel, because I've already done it, and it takes about, I don't know, maybe 5 minutes to run on my computer. Here's the result for the ammonia case, and as usual, you'll go to the energy ladder. And I've already selected the mesh view on this. And what you're looking for is are some orbitals that kind of look like the d orbitals that you just saw on the bare chromium. Now, none of those looks like d orbitals, especially. This one here kind of looks like a d orbital, but it's not a d antibonding orbital, because you see there's no sign change between the metal and the ammonium. So we just got to keep on going up, and until we see something that looks like some d orbitals around the metal. And look, there we go, there's one, and there's another one, and there's another one. So these look like they're triply degenerate, all 3 at the same energy, as you can see, and that's -21.4 EVs. And then I think we're going to see a couple more. Now, these are looking a little bit more interesting. There's obviously some sigma antibonding interaction between what looks like these d orbitals on the metal and the ligands. And that's sort of one of the things that you want to be paying attention to. It's it looks like this, and then once you go to the water complex, it'll have kind of these same features, but a few extra ones.